Hi, my name is Misha and I'm a co-founder of NetBird. In this video, I will demonstrate how you can easily set up and manage a secure private WireGuard-based network with NetBird. Let's get started and install NetBird. I use Ubuntu and I will proceed with the Linux installation steps that you can find at netbird.io/docs. NetBird also works on other Linux distributions or macOS or Windows. You can even run it on your router or Raspberry Pi. I will add the repository now and update the apt cache. Then I will install the NetBird agent package. The agent will start automatically running as a background service on the machine. NetBird also comes with a desktop UI application, which is a simple history app. I will install it as well. You can use NetBird app command in your terminal to connect to the network, but I will use this history application instead. I will open it up and click connect. At this point, a browser window pops up starting an interactive login session. Internally, NetBird uses OAuth2 device authorization grant to obtain an access token and register a device. I will confirm the operation, and now I'm prompt to sign up. With NetBird, you don't need to create an account up front. The system will automatically create one if you're logging in for the first time. You can choose to sign up with username or password, or a social login like Google, Microsoft, or GitHub. If you are using Google Workspace or Office 365 in your company, it will also work. I will use my corporate Google account. After a successful device registration, I will check the NetBird web panel at app.netbird.io. And there we go. My laptop is online, just connected. It has a private NetBird IP and my email address, indicating that I added this machine to the network. I can check the status of the NetBird agent on my laptop by running NetBird's status command. It displays the IP address, the type of WireGuard interface. In my case, it is the kernel interface, since I'm running Linux with the kernel WireGuard module. If I disconnect the agent, the web UI shows that it is offline. And if I connect it again, then it will be back online. Now let's add some more machines to the network. I prepared an EC2 node running on AWS. The installation steps are pretty much the same. I will add the repository and I will install the agent. I can't really use the desktop UI application, so that I will run a NetBird app command to connect to the network. I will then copy the verification URL to my browser. This will trigger device authorization flow just like before, and I'll click confirm to add my device. Let's go back to the peer step in the admin panel. And you can see that the EC2 node is online. I can ping it now from my laptop. What if you run your services on container orchestration platforms like Kubernetes or AWS ECS? In this case, you can run NetBird in a Docker container. I will copy the docker run command from the documentation website. Let's specify the container name. I'll simply call it Docker. I will use the same name for the host name. The host name will be displayed in the NetBird admin panel. I should also specify the setup key, and setup keys are pre-authentication keys that allow you to register machines at scale without triggering the interactive login flow. Let's say you use infrastructure as code tools like Terraform or Ansible and have hundreds of machines. Using interactive login through the browser would be just impractical. I will copy the key to the Docker command and I will run it. The Docker container is running and we can see it just joined the NetBird network. Going back to the Setup Keys tab, you can notice that the setup key was used just now and once. There are two types of setup keys, one-off and reusable. The one-off key can be used only once to authenticate a machine, and you can use reusable keys multiple times. The system creates two setup keys automatically, one one-off key and one reusable key. As an administrator, you can revoke setup keys and define the expiration date. When I added peers to the network, they could instantly communicate with one another. And this is due to NetBird's access control feature built on top of resource groups and rules. NetBird allows for granular access control in your network. The administrator can define what groups of users or machines can access network resources. NetBird automatically adds every new machine joining the network to the default group called All. The default rule creates a full mesh network where peers can connect to each other. If I remove it, I won't be able to access any of the machines from my laptop. So let's try pinging the EC2 node again. It is unavailable. Now let's run the status command again and watch it. I will now create a rule allowing users or employees to connect to the servers. I will hit the Add Rule button, name the rule devs to servers, and I will add devs as a source group and servers as a destination group. If group doesn't exist, NetBird will create it automatically. Now, the rule is in place, but it is ineffective because there are no peers in the groups. I can easily add peers to the groups on the Peers tab by clicking Groups in the table. I will add my laptop to the devs group, and all the rest I will add to the servers group. The updates are real-time, and you could notice that there are already two peers connected. So if I remove the group from my laptop, then the connection will disappear. And it instantly disappeared. I can add it back, and the connections are going to be back. NetBird also has an auto-grouping feature that allows adding groups to the setup keys and users. This feature simplifies network management, saving time and grouping resources. You can assign the devs group to a user, just like I did, and every new machine added by this user will be automatically associated with the group. We can do the same with the setup keys and assign the servers group to a setup key. Whenever this key will be used, for example, when provisioning infrastructure with Terraform, the machine will be assigned to a specified group. While we recommend installing NetBird on every resource, some cases do not allow for agent installation or can slow down migration from legacy systems. For example, there is a printer or an IoT device where a NetBird agent can be installed, or your private infrastructure counts hundreds or thousands of servers. In such case, you can use the network routes feature to access the whole internal private network without installing the agent. My EC2 node runs in the subnet 172.3180.0/20, and it has a private IP address in this network. There are also some other machines in this AWS subnet. I will now hit the Add Route button. We'll name the route AWS VPC 1. I will put the desired range 172.31.80/20, and I will select my AWS node as an entry point to the network. I will save the route and I can ping the services in this network now without installing the agent. So I can try pinging the private IP address. It's reachable. The same would work for other machines in this subnet.